Hi everyone, in this video we will be doing an OTDR training using the VeEX OTDRs and the FiberNet network simulator. So to give you an idea about these tools that we'll be using for the training, first of all, that's the network simulator box, which has got a fiber setup inside, like point-to-point and a PON network inside. We'll have a look through the OTDR how this network looks like from inside, the different losses, and the arrangement of that setup inside. As for the equipment that we'll be using, the OTDR, so we got a range of OTDRs that we can use from VeEX. They all got the same graphical user interface, so it doesn't really matter which one to use. They are all the same in terms of the user interface. The one actually that I'll be using for that video is the MTT Plus, the one on the right here, which is a modular platform with plugin modules. I'm going to be using the OTDR triple wavelength 1310, 1550, and 1625. So that's the one we'll be using. That's the OTDR, and these are the interfaces on the top panel. So we got the OTDR port for single mode and another auxiliary port OTDR, which could be for either multi-mode or the 1625 filtered port. You got two more ports, the optical power meter and the visual fault locator for testing. So this is quickly the tools that we will be using. Um, Maybe you can have another, you might be using a different VeEX OTDR. So that's the FX 150 Plus, that's the mini OTDR. As I mentioned, I've got all the same user interface. You won't be able to tell the difference once you're in front of the screen between the different models. So let me bring up my VNC screen. So I've logged in remotely to my OTDR. Um, so once you log into the units, you can see the IP address at the bottom left here of the screen. That's 192.168.1.47. You can type in that IP address to your VNC client or to your web browser, and it will bring up the screen of the OTDR. So we are looking at the home screen of our OTDR, and on the top left it says 1, this one here. Once you press 1, these are the test application modes we got on the unit. So we got OTDR modes, and we got other tools for optical testing as well. We will be starting with the just a brief OTDR test, and for that we've got different OTDR modes: the Easy OTDR, the V-Scout, and the Expert OTDR. And I'll just mention quickly the difference between the three. Have really much experience playing with OTDRs, how to configure the optical setup inside in terms of the pulses you'll be using on the laser. So the Easy OTDR would be the right choice to start with. Also, it's a good idea to use Easy OTDR when you don't really know what kind of network you're testing. So maybe you got the OTDR experience, but you don't know what kind of link you will be testing. And that's a good idea because the unit will use its own intelligence to decide what kind of optical pulses to use for testing. It will be doing that on your behalf. Um, Expert OTDR, that's one step higher, where you can configure the optical pulses and you have an idea about what you're testing and how you can test it. So it gives you full access to all the configuration of the optical pulses. The V-Scout in the middle here, that's the one when you need to make a mix of pulses, when you need to use mix of pulses for testing rather than using just one pulse to get a trace. And we will see the application of that one when we get to the PON network testing. The rest of the tools here, we can use the visual fault locator, an optical light source, and for the optical light source, you can use the same OTDR port to bring a laser, a continuous wave laser at 1310 or 1550 or whatever the wavelength you got on your OTDR. So it's using the same OTDR port. Optical power meter, that's the different port we have seen in the introduction. And also you can bring in your fiber scope from VeEX. It has to be from VeEX, so the drivers would be ready on the unit. And if you got an MPO switch from VeEX, it can be controlled from this mode as well. So let's start quickly with the EZOTDR. We're not going to configure much on that one. And just to give you an idea about what kind of link we will be testing. So that's the FiberNet toolbox, which has got certain different configurations inside, depending on what you want to test. So on the bottom here, you got on the left an SC APC, the green connector, and that's a point-to-point link here. It starts with a 500 meter slack, then a good splice, followed by another 600 meter slack. Then you got a bad splice, and we will be able to see how bad that splice is using the OTDR, followed by another 300 meter of fiber. And then we got a macro band here between that 300 meter and the next 300 meter. Again, with the OTDR, we will be able to see the losses on all these sections and all these events. So yeah, that's the bottom here, the point-to-point network. You can test with the OTDR from the left or from the right. So we will start the test from the left. You can try it on your own from the right-hand side. Later in that video, we'll be exploring the upper configuration here. These ports are related to a PON network. So we got a 1x4 splitter that connects with some 200 meter fiber and connectors to another 1x16 on the downstream. And then you got some ports at the end here on the right hand side. The one on the top right, that's the one connected through a 1000 meter slack of fiber. In the PON network configuration, we will go into more details how to test that downstream and upstream PON network. So let's go back to our VNC screen and look at the OTDR here. So we have chosen, as I mentioned, the easy OTDR mode. So I will use the 1310 and the 1550 for testing. And if you look at the mode here, it's dimmed already and it's in auto. So you can't really configure anything here because the unit will decide what kind of pulses that will fit such kind of a test. So let's go ahead and press start, and I'll show you later on how to configure the rest of that screen. But just to give you a quick idea how it works, you just select the wavelength and then press start. The unit will start progressing, and now you can see it says 1310 12 ns, 12 nanoseconds. So the unit decided to use a pulse width of 12 nanoseconds for that one on the 1310. Also, the unit decided on the test duration. I think it's like a 30 seconds test. So the unit decided for the pulse width and the duration of the test. Now that it has finished the 1310, it's going now through the 1550, and again it's using a 12 nanoseconds pulse. You can always click the unzoom magnifier here at the top right, just to make sure you are looking at the full link here. This is an auto-saving dialog. If you want to save or not the results, we'll come to that later on. So I'll just click abort and have a look on that link. So let's see what we got here. You got the gray part of the network at the left here, which is a 1 kilometer. So I'm using actually a 1 kilometer launch cable before going into the FiberNet box. So this doesn't count into the analysis. It's showing up in gray because it's there. It can be seen by the OTDR. However, it's being counted as a -1. So the 0 kilometer is actually where the fiber net box starts. So the first one, we got a quick splice at the beginning, which is pass, and then followed by a fiber span, and then followed by another splice, which has got a loss of about 0.5 dB. Now it says fail because the thresholds on the OTDR settings has got a certain limit, and this one has exceeded the limit. We will see how to configure the thresholds later on, and then another section of fiber, and then our macro bend here. So it says a macro bend at about 1.4 kilometer, and we were expecting to see a macro bend. And finally, we got the last 300 meters before going to the end of the fiber, which is a pass in terms of the losses. So that's quickly how the link map looks like. Again, on the top, these numbers 0.000 and then 1.097, that's the accumulative distance from the beginning of the fiber enter test. So we can see we have 1.698 total distance, and the numbers at the bottom of the icons here, these are the incremental or the differential of for each fiber section. So we got a fiber section which is about 1 kilometer, another which is about 300 meters, and finally we got another 300 meters. So on the top is the accumulative, on the bottom is the separate or the individual length of the fiber. Summary is at the bottom here in the blue ribbon. 1310, these are the measurements regarding the 1310. Remember, we did a test using 1310 and 1550. So all these numbers are relevant to the 1310 test. Length is 1.698 as a summary, and the total loss of that link as a point-to-point is about 1.1 dB, and the optical return loss is 37.2 dB. So far, these numbers are fine in terms of the total loss. Now, if you need to have a look on the 1550, just click on that turnaround arrow, and it will show you the numbers for the 1550. So that's a quick summary. On the preview menu on the right hand side here, you can click on which part you want to see. So you can slide that box here, and you will be able to see the relevant trace in the next menu. Now if we go to the events, we would be able to see the fiber trace itself. If you click the unzoom here, you'll be able to see the full screen, the full fiber trace. So that's our fiber trace for the 2 wavelength. The one selected here is the 1550. So all the measurements you're seeing is for the 1550 nanosecond. And you can see the individual numbers. So of course the link map is much easier to interpret compared to a fiber trace. If you would like to zoom in the vertical direction, you've got the plus and minus on the right hand side here. So that's plus, 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 and you can zoom out. Similarly, for the horizontal zooming, you can press the plus and minus, and at any time you can unzoom for the whole display. If you would like to zoom for a certain area, that's the box here, the zoom box. Just click on the part that you're interested in and start drawing a box. Drag and draw a box, and automatically the unit will zoom in into that part. You can see a preview on the right hand side. This is what you're looking at on the link. You can slide that rectangular box to the left and to the right or anywhere. And you can unzoom at any time. If you would like to lock that screen, just in case by mistake you press a zoom in or zoom out or anything, that's your lock icon here at the right hand side. Now this one is locked, you can't really change anything on that screen. If you try to zoom or unzoom, take two. If you like to do some manual measurements, like a 2-point loss or reflectance or splice loss, you can do it here from that menu. Bring your markers and set them at the place you would like to make the measurement between the 2 points. And at the bottom here you can see where each marker is, the difference between them in kilometers, and the loss between the two markers. If you'd like to make a splice loss measurement apart from what the unit has detected already, you can customize and put in a measurement for a splice loss. So just drag your markers for the measurement, and the measurement for the splice will be there. So yeah, that's the two traces we have done, 1310 and 1550. This is a summary of our measurement using 12 nanosecond and a link distance of about 2.1. That's the measurement range, not the link distance itself. So 2.1 is the what you can see here on that scale down here. So if you want to test a 1 kilometer fiber, typically you want the measurement range to be double that. If you want to test 10 kilometers, make the measurement range up to 2 kilometers. We'll get into that in more details in the expert OTDR mode. So yeah, that's the easy mode. We haven't really done much on the configuration, just push the start button and we got the measurements quickly. Now let's go exit that mode with the red cross here. Do you want to exit? Yes. Now let's go back to 1 and select now the expert OTDR mode. Alright, so now that we are in the expert OTDR mode, you've got now the mode auto available for you to choose. Is it manual, auto, or the different other modes? Previously in the easy OTDR, we couldn't really select that drop down menu. It was set to auto and you can't do anything about it. Now I'll go to manual mode and show you how to configure it. So we know beforehand that we are measuring a link distance which is about 1.7 kilometer. So you can set the distance to 2 kilometers or higher, maybe 6 kilometers if you would like. And then choose the pulse width. Remember in the easy mode the unit decided to go with a 12 nanosecond, so that should be sufficient to use a 25 nanosecond pulse. Resolution, you can choose auto or high or medium or low. And the duration of the test. All these parameters were previously selected by the unit, but now you have to configure them manually. That's why you need some kind of experience, what sort of numbers you need to put in here. And what kind of optimization the unit will make with these pulses. Is it for dynamic range or for a dead zone? So let's go with a dead zone. The next thing that we haven't configured before are the parameters here. So what kind of fiber you will be testing, because each fiber is different from the other from the manufacturer specs point of view. So you can choose from some presets here. I've already put here what's called a fiber net, because I know that this is the fiber sitting inside my fiber simulator toolbox. But again, you gotta big list of different fibers, G65.2D, G657. Yeah, and you can customize your own as well. So we bring in the specs from the manufacturer spec sheet and put it here. Now let's say you want to customize your own fiber. You type in the refractive index, the RI, and the backscatter coefficient for each wavelength. This information is available from the manufacturer. So if you want to save or customize a profile, you click on modify and click add, and then you will be able to add your own profile and type in your own numbers. PNF thresholds, the pass and fail thresholds. If you got your own profile, it will be here. If you want to customize one, just go to the pencil icon and you will be able to see the different pass and fail thresholds for the different wavelength for the different events. So let's say, for example, this one, 1310, the splice loss limit is 0.1. So if you would get a loss for a splice which is 0.15, it will be tagged and flagged red in the test results. So these are the default, but if you would like to customize, just go to custom, and yeah, it's available for you to type in all the numbers you need for the acceptance. Once you're done, you can just modify and click add, and then you can give it a name, whatever profile you need to be using later on. Next is the splitter thresholds, the S thresholds. So if you are using a PON network or you have splitters, these are the minimum and maximum limits for each type of splitter. So if it's a 1x2 splitter, you can expect half of the power will be split. That's a 3 dB loss, and you should be okay to go up to a 4.5, depends on the manufacturer. If it's a 1x16, and we will see it later on when we come to the PON, we got a minimum loss of 12 dB and a max of 15. You can customize these as you want. And then we got the analysis thresholds. So you define what's the what is a splice loss. So if it's 0.1, it will be identified as a splice loss if you got a 0.1 dB loss. If you get a reflectance back of 65 dB, this will be classified as a reflectance. And the fiber end will be classified when the OTDR sees a 5 dB loss. So this will be seen as a fiber end. And a macro band is actually a higher loss of 0.2 dB. Again, you can customize these values and create your own profile and put in your own numbers for the analysis thresholds. So yeah, before we start, let's have a look also on these buttons. The autosave button. So this one is for how to save your test results, what kind of naming and file architecture you want to use when incrementing from one fiber to the other. So it's going to be autosave. I would like to autosave the test results, and please ask me before saving for each test result. What are we going to increment when moving from one fiber to the other? It's the trace ID. So the trace ID is the thing that we're going to increment, not the fiber ID. You can still use the fiber ID for incrementing, or ask the unit to come back and ask before measuring is going to increment the fiber ID or the trace ID. Job ID, this is just simply a name you can put in here. Could be the site name, could be the room name, could be the whatever the project name is. Yeah, this could be a project name, the job ID. Cable ID, if you got a bunch of cables, then you can put different names for the different cables. And then you got the fiber ID. So as you can see, I'm using this for my project here for the training, and I've given it the name for FiberNet box. And the cable, I'm gonna call it cable 3 maybe, so we can have some fresh new results apart from the one sitting already inside the unit. And the fiber ID is going to be a point-to-point because we have seen on the fiber simulation box we've got a PON and we've got a point-to-point. So I'm gonna put some identification here to be a point-to-point. You can put more information if you would like in the file naming, the wavelength, the pulse, or the serial number, but that would be too much to put in the file naming to read. You can start with a fresh index 001, or you can resume from a previous index where you stopped. Common information for all test results would be the node ID, the account, the technician name, technician ID, and was it A to B test? Are we testing which direction we're testing? Is it A to B or B to A? So you can put that information here. This information is important about the original and the termination location A to B and B to A when you're doing a bidirectional test. So for the same trace, for the same fiber, you do it A to B and then do it again from B to A. But then you have to put information here that the original location is B and the terminating is A. So the OTDR will be able to combine these two into a single bidirectional analysis. And you might want to take that PDF report if you want to get on top of the SOR file the PDF report. So we get two files, the SORS file and the PDF. So let's press start again. It's the same test setup. We have the point-to-point, but now with the Expert OTDR we've done some manual configuration for the pulses, and let's see what we'll get. Now you might have noticed that the noise part now is a little bit big because we set the measurement range to be up to 6 kilometers. In the easy OTDR mode we have seen purely the trace and very small part of the noise level because the unit decided to go up to about 2.1 kilometer of measurement range. Now it's almost finished with the 1310 25 nanoseconds. And it started the 1550 nanometer 25 nanoseconds. While the test is running, you can still play with the markers at any time. You don't have to wait until the test is over. If you would like to move both markers simultaneously, just click on the thick part at the bottom. Alright, so we got a fresh trace ID 001. It's going to be under cable 3, and that's the confirmation before saving. I'll press OK and it will be stored inside the unit. Alright, so what we got here, again, that's our fiber span. At the beginning it's just 1 kilometer. It's not being counted into the analysis. It doesn't count to the total distance of the link. And then we got the first fiber span, which is 1.1 kilometer. Now let's go back and see what did we have on the FiberNet toolbox. So we had 500 followed by 600. That's a total of 1.1 kilometer, and there's a very good splice in between. You might not be, an OTDR might not be able to see that good splice sitting in between. So the fiber span by the will be seen by the OTDR as a 1.1 kilometer, and that's exactly what's being shown here. It's a 1.097, almost 1.1 kilometer. However, the losses have exceeded the thresholds we have set. So we're getting 0.368 for 1310 and per kilometer, and for 1550 that's a 0.219 decibel per kilometer. I'm pretty sure if we go back to the settings, to the thresholds, we will see that at 1550 the maximum is set for the thresholds is 0.2 only dB. Now this one is 0.219. That's why it has been flagged red. Let's go back to our setup and let's have a look on the pass fail thresholds. What do we have on the 1550, sorry. So a splice, yeah, the attenuation decibel per kilometer, that's the one here, it's 0.2. That's why when we got 0.219, it has been flagged as a failure. Now it depends on the margins and the acceptance criteria for the project. Now, what's after that 1.1 kilometer? We got a splice which is bad, which has failed. So that's a 0.5 dB loss for both 1310 and 1550. Typically a splice is 0.02 dB or even less when it comes to a good splice. So this one is a bad splice. Let's go back and have a look. Yeah, this is our bad splice here after the 1.1 kilometer, and the unit has detected that splice with a loss of 0.5 dB. Now next is another fiber slack which is 300 meters, and we got a loss of 0.202 dB per kilometer for the 1550, which is still beyond the threshold of 0.2 dB. That's why it has been flagged as a fail. And next comes the macro bend. The macro bend, as mentioned here, there's a macro bend at the FiberNet toolbox, and it's showing 0.7 dB loss. So this has not been classified as a splice loss or a bad splice. It has been smartly identified by the unit as a macro bend. So that's a big difference between a bad splice and a macro bend. Now the next is on our link is the last part of fiber spans. That's a 300 meter, which seems to be good. This one has passed actually. This one is 0.3 dB for the 1310 and 0.196. 0.196 is less than the 0.2 of the threshold. That's why it has passed. Now overall that link is a 1.698 kilometer, as you can see in the blue ribbon at the bottom, and we got a total loss of 1.1 dB. So that's the interpretation of our link map. Now if we go to the events, we have seen before the different traces and the different events if you want to have a look on certain events, or do a manual measurement from the measurement tab here. You can do a 2-point loss, reflectance, or a 2-point attenuation. Yeah, let's now go to traces. Have a look here. So we got two traces, one for each wavelength. And now we got results sitting here. This is the area where you see all your projects, all your cables, all your traces. So I've got cable 3. This is my current project, and I've done only one test on that fiber using 2 wavelengths. That's why it's showing as a single intro here. The blue and the orange color, 2 different wavelengths on the same fiber. You can press save or maybe load something from the cloud. So save will save that result internally. It's already saved. Load means that you want to load that. Maybe if I go back to an old one I did in the past here, and I go to cable straight 002 and I press load. Now the old trace will be loaded for me to display on the screen. Now you can see here it has been loaded, and on the top the unticked ones, these are the measurements that we just did a minute ago. and the ones on the bottom, these are the measurements done in the past, and I have loaded them to look at them. Right? Now, which one you want to see, just click on these boxes and you will display all these traces. If we go to events, now you've got 4 traces displayed. Back to traces, untick the old historical ones, and now you got the fresh ones here. Only 2 traces left. Alright, now something interesting if you would like to look at here. Now this one with the hyphen, it says 1310 with a hyphen. Hyphen means that's the trace being edited on the events. So that table, all these numbers are related to the 1310. If you would like to see the trace and the numbers of the 1550, just mark that one, highlight that one, and click activate. Now the 1550 is the active trace on your screen, meaning if you put in here some markers and all these numbers are related to the 1550, you can still see the 1310, but all the numbers on the display are related to the 1550. So only one trace can be activated at a time, but many traces can be displayed at the same time. Now, since we've got the 1310, I'll just unclick that one. I just want to see the 1550. So you got a single trace. Now, remember that the link map, for the unit to build the link map, it's going to use all available traces you've done during the test. So we have done 1310 and 1550. So the link map used both traces to build that map for you for that link. Now let's assume that I would like to only have a link map based on 1550. I don't want the unit to use the 1310 to build the map, just the 1550. So go back to your map. Remember here that we have only ticked the 1550. Now go to your link map and do a rebuild. So the rebuild will use only the visible traces to rebuild our link. Now you might have noticed that the macro bend is gone. It's not gone actually, it's there with the loss. It's still 0.7, but it's not being interpreted as a macro bend. So the more pulses, the more traces you have, the more the unit will be able to aggregate this information together to interpret or decide if it's just a splice or is it a macro bend. So it's better to use multiple of pulses or multiple of wavelengths so the unit can identify it properly as a macro bend. The loss is the same, but it's just the interpretation. Now let's assume that you got already that trace and you know beforehand that this one here is a macro bend. So you just highlight that one which says a splice and we know it's a macro bend. Go to modify and tell the unit, we're doing this manually now, and tell the unit this is a macro bend, this is not a splice, and click OK, and there you go, you got a macro bend. So again, you can customize any of these losses, depends on what kind of if you already know beforehand what that loss represents, if it's a macro bend, if it's end of the fiber, if it's a connector, if it's a splitter. So you can still highlight that section and modify it to be the one that you already know. So that's the type of losses you got here. You got the full library here. Alright, one thing to note, if you would like to save your results both on the internal storage of the unit and the cloud, here on the right hand side in the configuration, in the setup tab, you got the cloud button. So you go to fiberizer.com, you create a free account. So fiberizer.com is a free service, and you can use your email, create a password to have an account on the fiberizer.com website. And once you do that online, go back to the OTDR, put in the username and password as you can see here, and then connect to that cloud. So when you go to results, what you see here are the results stored inside the unit. But if you would like to synchronize it to have another copy of these results on the cloud, just click on the yellow push here, and it will synchronize all the test results between the unit and the cloud. Now it says in green in sync, so whatever on the unit has got a backup on the cloud as well. We'll have a look quickly on Fiberizer once we're done with the OTDR testing. If you got a USB and you want to export the test results to it, just highlight which ones you need to export, USB export. If you want to export everything or only the selected, if you want to export a tree, flat, or a group. So you got multiple of options what to export to the USB. And that's for the expert OTDR mode. Now I'll quit that one. I'll quit that mode and have a look now on the final and the third and final mode of OTDR testing, which is the vScout link map. So next in our video we will be looking at the third and last mode of OTDR, which is the vScout, the one highlighted here, the vScout link map, which is mainly about using a mix of pulses, different configuration of pulses, to construct one single link map and use the information from the different pulses to build a single link map. So let's start this mode. The idea behind having different pulses is that one single pulse might work for a certain distance, a certain configuration, while a different pulse width might work for a different configuration. Let's take, for example, a very short link distance, which is, let's say, for example, 10 kilometers. If you're using a short pulse, that would be sufficient. But if you have a link distance which is about 100 kilometers, then you need to use a pulse width which can reach that the end of the link. However, the big pulses like the 500 nanosecond pulses, which can reach the end of the link for 100 kilometers, using that 500 nanosecond pulse might be too strong to characterize what's happening at the beginning of the link, and you will start getting a dead zone for that pulse width. So if you're using a mix of pulses, you're getting the best of all worlds, the short dead zone, the high dynamic range from the different pulses. So let's start now with the vScout and see how it works. So on the mode here it says vScout, it's dimmed, you cannot change it because we have chosen the vScout mode. On the profile you can select your profiles. I've created one here which is called Fiberbox, point to point, and let's see with the pencil icon what's inside that test parameter. So we will be testing at 1310 and 1550. On the test parameters, the ones with the asterisks are the pulses to be used on that test. So I've selected the 3 nanoseconds, which is ticked here. 5 nanoseconds will not be used. 10 nanoseconds will be used. And then I've got the 500 nanoseconds, which will be used as well. Now, so I'll be using 3 different pulses for each wavelength. And each pulse can be configured separately. So with the 3 nanoseconds I'm going with a high resolution, and I might just put like 15 seconds. the duration of that test. And then on the 10 nanoseconds, I might just go quickly with 5 seconds, which should be sufficient. If you're using really vScout, a mix of pulses, then you don't really have to go with 1 minute and 2 minute pulses, because the overall duration of the test will be too long. Remember that on the 1310 we'll be using 1, 2, 3 different pulses, and then for 1550 we'll be using 3 more pulses. That makes 6 different traces. So you can imagine, if you're using 1 minute duration for each pulse, that makes the whole test about 6 minutes, which is quite long, and you're not getting much information from the extended test duration. So 5 seconds should be enough. 5 to 15 seconds should be enough. And that one I'm using here is also 500 nanoseconds. Remember to set the distance, the measurement range, to be double what you need to test. So if your fiber is 10 kilometers, you need to set the distance to 20. If your fiber is 30, then you need to set it to 60 or more. So always use you always use double the distance when measuring. So since we know already that the fiber box here, let me bring back my screen. The fiber net box here, for the point to point at the bottom, it says 500 plus 600 plus 300 plus 300. That's about 1.7 kilometer. So we need to take into consideration about 2 or more kilometers when setting the distance in the configuration here. So that should be it. We're ready to start. So one more thing before we start. On the test parameters here, you will notice that once you have selected 6 kilometers, the unit have disabled access to higher pulses like the 1000 or 3000 nanosecond pulses, because it doesn't make sense to use such big pulses on a short distance. The whole link might be just a dead zone. So these options are not available anymore. But if you want to get access to these, you need to tell the OTDR I'm testing a longer link, a bigger link. Let's say I'm testing a 40 kilometers. So now you have access to the 1000 and the 3000 nanosecond pulses, because these pulses are designed to reach such kind of distances. Alright, we'll set it back to our 6 kilometers. And I might just go with the 100 nanosecond instead of the 500, because we have seen in the expert and auto mode the OTDR was happy with about 12 nanoseconds or 15 nanoseconds, so there's no need really to go to bigger pulses. So on the 100, that's 5 seconds, and we'll just keep it for dynamic range, while the 10 nanoseconds we'll keep it for dynamic range as well, and do a 15 seconds. So we got 15, 15, and 15 seconds. So that's a total of 45 seconds for each wavelength, making a total of about 2 minutes for both wavelengths. So we should be ready to start now. Now it says here 12, it's a countdown here on the timer, the red timer, and it says between brackets 6. That means we've got 6 traces to go. Alright, so we're done with the test here, and this is how it looks like. The link map utilizing all of the 6 traces we've done. So on the traces tab you can see we got 3 pulses for 1310 and 3 pulses for 1550. And these are the 6 traces. Of course it's too much to interpret while they are on the display, but you can only display one at a time if you want. Just untick these boxes and you will be able to see one trace at a time. The link map is built from the whole 6 pulses. Now you can see there is the OTDR has detected the bend again, the macro bend, which is about 0.7. Now macro bends are hard to detect using 1310. Usually they are the bend sensitive fibers can be detected by the macro bends can be detected by 1550 or 1625. Now the unit have seen a loss of 0.7 dB on 1550, but there was no loss on the 1310. Now if that was a splice, we should have seen also a loss at 1310, because a splice loss is typically the same for 1310 and 1550. But however, the unit couldn't see a loss at 1310. So the unit decided that this one is not a splice, it's a macro bend, because it gives losses on the 1550 and no losses on the 1310, and that's the main characteristic of a macro bend. Just in case if the OTDR shows you an event or interpret an event to be a macro bend when you are pretty sure it's a splice, you can simply modify that icon here and say, okay, this is not a macro bend, I want to modify it and make it a splice, and then it will look like a splice. The loss is the same, it's just the symbol and the interpretation on the link map. So I'll bring it back again as a macro bend. Alright, so let's have a look now on these colors. We've got the link map, the overall diagram of the link distance. At the top, the gray part, that's the launch cable box, and then we've got a red part, red section, and that's actually the one here, the 1.097 kilometer. So that's the part that has failed, and you can see there's an arrow pointing at the section of the failed part of the link. So if it's a pass, you will see it in green, like this one here, the 0.303, and the pointer is showing where that part on the overall diagram. And then you got a fail again at the last 300 meters here, this one. Right? So yeah, we've seen the losses. We have seen the bad splice here. That was a bad splice of about 0.5 dB. We've seen the macro bend, and we have seen the three different slacks. Let's bring back our diagram, how it looks like. Yeah. So we've got the 1.1 kilometer, which looks fine. Actually, there was where that one? Yeah. So the total loss on that 1.1 kilometer has failed to be below the threshold. However, we can modify the thresholds to make this one pass. It depends on the pass and fail thresholds of the project. And then you get a bad splice. This is where we got around 0.5 dB by the OTDR. Another slack of 300 meters, and then the macro bend, and then the 300 meters. Let's see this one again. The 500 and 600, that's the 1.1 kilometer here. And then the bad splice, 0.5, and then 300 macro bend, and then a fiber of 300 meters. Now, you don't want really to repeat the test just because you forgot to put the right thresholds. You can simply go back to your setup, go to the pass and fail thresholds, and then on the attenuation per kilometer, let's say that's the one I need to modify here on the 1310, I'll set it to 0.35, maybe 0.38 dB, and that's the maximum limit I would accept for my fiber. Now you go back to your link map. Now you need to rebuild to take into consideration the new pass and fail. So you tick on rebuild. Let's see what's the failure here is saying. Okay, now the 1310 has passed, but however the 1550 is 0.228, which is still beyond the 0.2 dB for 1550. We can still modify that one on the pass and fail thresholds. Let's say 0.27 dB. Okay, you go to your link map and rebuild to take into consideration the new thresholds. Alright, so we got pass for all the three fiber slacks, and for the bad connector and the macro bend, they are still a failure because of the high loss. So that's the interpretation on how to do pass and fail analysis. Now you got your traces here, the 6 traces, and if you want to store these as we did before, they can go into your cable 3. That's our current project, and the traces we just did has got the name 004, so it's already stored inside the unit. You can press the push button here in yellow and it will synchronize with your fiberizer as we did before. Now let's see the individual effect or the individual diagram of the link from a single trace. Remember that this diagram is built from a mix of traces. So I'm going to deselect all of them and I'll just ask for the 1310. That's the trace for that one. 3 nanoseconds, 1310, nothing else. And go to my link map and ask to rebuild the diagram based only on that visible trace. So I've got only one trace visible selected, and I need to know how the link will look like if it's just one trace. Obviously that short pulse on 1310 has got really no information for us. It's just showing the total link of 2.7 including the 1 kilometer of the launch fiber box. So I would say that's a useless pulse for us. Now let's see what the other pulse, the next bigger pulse, 10 nanoseconds, could show us. That's the trace for it, 10 nanoseconds. And let's see how the link will look like based on that pulse. Now it's starting to show some further information. You can see a total of 1.1 kilometer here, the bad splice, but that pulse couldn't detect the macro bend. Remember we mentioned that the 1310 is not sensitive to bending. So it's just identified 600 meters. These are the 600 meters, the 300 and the 300. And it couldn't detect something on the macro bend in between. So it's just showing the total of both. Now let's bring the same pulse but from 1550. So that was the 10 nanoseconds 1310. I'm gonna bring the 10 nanoseconds from 1550 and see what's the difference between the two wavelengths then. Alright, the 1550 could detect that loss. It's detected as a splice. The loss is correct, it's 0.7. It's being detected as a splice. However, when you combine both 1310 and 1550, the unit will be then able to confirm that's a bending loss. Right? I'm gonna rebuild the link map based on two pulses. You see there? The unit has identified it as a macro bend because we're not getting a loss on 1310, but we're getting a loss on 1550. So that's pretty intuitive from the unit. It has got smart identification of the different losses. Alright, so that was for the vScout. We will see the vScout again on later on in the video with the PON structure because it's pretty useful for the PON structure networks. See you on the next part of the video. Right, in this part of the video we will have a look again on the vScout, but this time it will be through the characterization of a PON network. So let's see how our PON network looks like on the Fiberbox simulator. That's the top part of that is the PON. We have seen already in the previous part of the video the point-to-point at the bottom. Now the PON network is the one with the 6 connectors right and left at the top. So we will start first with a test from the top left connector here, which is the input for the 1x4 splitter. But first we go through a 1 kilometer of fiber slack, then we go to the 1x4 splitter, and then you have the 4 different outputs. Now on output number 3, that's the longest path, because it will go through another 200 meters, while output 1 and 2 from the splitter will just terminate on a connector. So the pulse coming out of the 1x4 splitter will see a longer path, will just continue to flow across the 200 and then go as an input to the 1x16 and then comes out on all output ports of the 1x16 splitter. Again, the pulse will continue to propagate through the 1000 meter and then terminate at the top right connector here. With the OTDR, the pulse will simply continue to flow as long as there is a fiber path, an optical path for it to flow. And the OTDR trace will be showing that longest path down that link. So let's go to our OTDR and see how that works and start our vScout. Now, one thing to note here is that the OTDR, to deal with PON network and splitters, the OTDR software must support PON networks. So typically with the VeEX OTDRs, you don't have to buy anything special for that. If you got up to 2 splitters, all VeEX OTDRs can support that without having to buy special hardware or special license. If you got more than 1 splitter cascading in your PON network, then you need to get a PON optimized OTDR. If you got like 3 or 4 splitters on your link, then a special PON optimized OTDR is required for that. Some entry-level OTDRs from other manufacturers, they will not be able to support PON characterization. That means they will just shoot the trace, but you will not be able to see on the link map a splitter diagram, a splitter icon there. Right, so let's see on our OTDR. Now, this one is vScout, as we mentioned before. However, it's not point-to-point anymore. I'll bring a different configuration, which is the FiberNet PON. Let's see how that configuration looks like on the vScout. So I'll be testing on 1310 and 1550. And on the test parameters, I've got 325 and 500 nanoseconds selected. It's going to be 15 seconds for the 3 and quickly 5 seconds on the 25 and then 100 nanoseconds for 5 seconds. That's for the configuration on both 1310 and 1550. Now, going back to what we mentioned before, the distance, it's 6 kilometers. Let's see if it's going to be 6 or not, just to estimate. We've got here 1 kilometer and then 200, that's 1.2, and then you got another 2, that's it's 1.2 and another 1, so it's 2.2. And remember that you got 1 kilometer of launch fiber box, so that's a total of 3.2. So it's pretty good to adjust your OTDR for a 6 kilometer configuration here. Now, the one thing which makes a big difference between testing a point-to-point and a PON network is the network tab here. You need to tell the unit, I'm going to be testing a PON and not a point-to-point. So once you mention point-to-point, alright, the unit is fine with that, but once you mention PON, the unit will ask you, okay, what kind of splitters you have on your network. If you don't know, you can set it to auto, but if you already know, you can set it to manual and mention what kind of splitter you have, the first one and the second one. So let's leave it to auto and see how the test result will look like. And I think I've got also the Alright, so now that we have tested the PON network, so just quickly, what was the setup? Our setup was 325 and 50 nanoseconds, 15 seconds for each, 6 kilometers measurement range, and our network was an O2 PON. We left it up to the unit to detect the splitters on the link, and the OTDR came back with that link diagram. So let's inspect how it looks like here. So again, that's our first gray 1 kilometer of fiber. This is our launch box, and then we got the first connector, and then we got a first span of 1 kilometer, which has passed the pass and fail thresholds. And then you got the first splitter detected here, and it says 1/4. So the OTDR was able to see the splitter and even detect what sort of fiber splitter is that. And in terms of the losses, that was fine for both wavelength. And then there's a merged event here. It could be a connector following the splitter. Let's bring back our setup here. So yeah, after the 1/4 splitter, you got connectors, a couple of connectors here between the two, on both sides of the 200 meters. So again, that's your 200 meters a pass, and then your second splitter, the 1/16 splitter, and this one has passed as well the losses, and then your last 1 kilometer of fiber, which is fine as well in terms of the pass and fail. So a total length of 2.18 kilometer and a total loss of 23.4 at the blue ribbon at the bottom. So this is how to interpret the link map. So you got a bunch of traces here, which are really tricky to look at. You need to go one by one if you want to analyze each of them, but the link map is quite informative and easy to interpret. These are a bunch of traces here, the 4 different traces and 4 different traces. On the results, we should be able now to see 2 different trees under cable 3. One was the P2 point to point we did before, and now we got the PON here. That's our remember we have how many traces we mentioned? That was 8 traces. However, in the project it's being seen as just a one test. So that's a single test containing multiples of pulse widths. So that's pretty much it for the vScout with the O2 PON. Now you can try and see how it looks like if you would like to give it as a manual and say I've got a 1/4 and then a 1/16, so it's not auto mode anymore. I might just skip the 3 nanoseconds pulse this time, and the 100 nanoseconds pulse as well, just to keep it short. So we've got 25 and 500 nanoseconds. And regarding this one, this is for the dead zone. You can actually leave it auto for both and let the unit decide. So the OTDR from VeEX has got really some smart information to deal with the different configurations and be able to sense what's out there before starting the test. You don't have to think much about the test. If you leave it to auto in the EZMode or the auto PON or the auto point to point, the OTDR will be able to sort it out for you. Once you get the information from the auto modes, then you can use the pulses which the OTDR have decided to use, and you can start playing around these pulses for some fine tuning. So yeah, we got here 2 pulses. Let's see what we will get from that configuration. Right, so once again we got two splitters and we got our first 1 kilometer of fiber after before the first splitter. Then between the two splitters we had our 200 meters. 1 kilometer detected, then 200 meters, and in between was the 1x4. And then we got the second splitter, and then you got your last part, which is a 1 kilometer span. So yeah, with just two pulses we were able to detect the network and see the different splitters on our network traces. So that's another list of traces, just 4 of them. And in your project the 4 traces will show up as another single test here. So that was for the OTDR vSCOUT mode. And now we will move on to some information about result management and file and result management. So now that we have recorded some few traces and test results, let's see how to deal with them from the file management. So go to your Tools, Utilities and Files section at the left hand side. Go to Files and click on Saved. You should be able to see all the test results that have been made. That's page 106. You can sort out by date or sort out by name. And of course you can see these are all SORS files, the Telecordia standard. And you can lock some test results at the right hand side so they will not be deleted by mistake. You have to unlock them first to get deleted. Now let's go to the last page. Yeah, so that's one of the test results we had. And you can see also information about the cable 3. That was the name of the project, so you get to know which project you were working on with that trace. If you want to view it, click on the view on the left bottom side. So this is how it looks like for the test report. You get the measurements, the link map, you get the trace and the individual events being characterized for each wavelength, very detailed actually. And what was our measurement parameters, so the different pulses and the different resolution and the different duration, and what was the fiber being tested, the refractive index and backscatter coefficient, the specs of the fiber being tested, and the pass and fail and the analysis thresholds. So that's typically how the PDF report will look like. Of course, the SORS file is just the trace, and you can analyze that trace if you want with any OTDR analysis software. The one from VeEX is the Fiberizer, and we've got actually two versions, one on the cloud, which is a free one, and one on the PC, which is also free. So if you highlight one of these traces here, we already have seen how to view it. You can delete it, you can upload it to your cloud, and if you got a USB plugged in, you can push it to the USB. If you got a trace on a USB but you want to load it on the unit, that's going to be from USB button here, so you can bring it from the USB and download it to the unit. Bluetooth, if you want to push that test result to your mobile, which is running the Fiberizer app. So with the Fiberizer app on your mobile, you'll be able to communicate with the unit via Bluetooth and exchange results between the unit and the tester and your app. Now let me bring my browser to show you the Fiberizer cloud. So type in your browser the Fiberizer cloud, cloud.fiberizer.com. If you don't have an account, you can create one. It's free, it's lifetime, no license for that. When you sign in, you should be able to see the projects which have been loaded to your cloud. Okay, yes. Go to jobs, and we should be able to see the FiberNet box, cable 3 that we did, and we got the point to point. We didn't actually synchronize the PON results from our last measurement. So we had two measurements, one for 1310 and one for 1550. That was for the point to point. That's the link map. If you want to see the trace, just go to the trace here on the top right, and you can see the different information about the date, time, the setup. And if you need to look at the report, the same one we have seen on the unit, you can still see it here as well. And if you go to that PDF version of your test result, so that's the PDF version. Very detailed, very comprehensive, and easy to interpret. If you would like to put a company logo or customize that template, you can do that from that button here on the left hand side. So these are the different templates. You can customize one of them. Let's say you can customize the basic one and give it a name, let's say basic NBN, and then you can customize what goes onto that report and the different sections on that report. If you want to do bidirectional analysis, that's the A and B. So all what you need to do is to upload the two traces, one for AB direction and the other one for the BA direction, and the unit will be able to analyze both in a bidirectional analysis mode. So that's pretty much it for the Fiberizer cloud. If you got a VNC app or client, it's typically the same like the unit itself. Type in the IP address of the unit. Let me just bring here. Okay, it says 192.168.1.47. I'll type in the IP address. Right now I've logged into the unit. If you need to see a VNC screen, type in the remote control, and the default password is pass1. So now you can see what we have seen on the VNC. So that's my VNC here, and that's my browser here. So there's no limit on the number of users who can log in simultaneously to the OTDR. So you can launch a couple of VNC applications logged into the same unit and a couple of browser tabs logged into the same unit. You got the manual here if you would like to read it. Test results, the same. You can download any of these. So just take the ones you need and click the download. You will get a zip file for these two traces. The zip file will contain the SORS file and the PDF. Screenshots, if you took any on the unit, so there's a button, there's a hard key button on the unit. You can take some screenshots rather than test traces. You will find these screenshots sitting here. If there's a new firmware update coming from VeEX, which is free by the way, download the file from VeEX website. I'll show you how to do that. Go to VeEX website, and I'll put in Entity Plus. That's the you can just type in your model number. That's one way to get it. Go to the product page. In the resources section, you should be able to see the latest software. It says 3.0.4998, and on top of it you'll see a PDF for the release notes. That's one way to do it. Or you can just go to the support section, which I typically recommend. Do a product registration for your unit. It's a free account you can create. You will not get any spam. It's just registering your products, and you will get notifications once there is an update about your unit, your serial number. There's also another way to do that. Software updates. You type into the last four characters of the test platform. So the last four characters of the serial number, you type them in. I'll type in that one. Let me show you how to know the serial number on the unit. So go to utilities, and actually it's on the back of the unit, but if you want to see it on the software, it's already there at the bottom. SNTMAA, that's the serial number here. If you want to know what kind of software version you're running on, and that's really important to keep the unit running on the latest and greatest firmware. In the About section, you should see the module software version. That's 3.0.4998. It's the same like the one we have seen on the website. And the main platform has got also a software update, which is 3.0.08. So if you go back to the website, we said that the serial number is TMAA. TMAA, and submit. Now it will list for you the list of compatible softwares that goes into your unit. Now we were working with the OTDR module, so that should be the 4010 plus. So that's another way to make the updates. There's also another way to make the upgrades through the VExpress section here under utilities. You go to VExpress and you click on check, and the unit will check on the server based on that serial number if there's any update, any licenses you have recently purchased. So once you get the unit and you decided to do any kind of additional license for a special feature, the license will be enabled for you through the server through the VCheck. It says register and authorize. That's good. We go to licenses enabled, so you can see the list of licenses enabled on your OTDR. If you want to check what's the software upgrade, it says your local version is 3.0.4998, and on the server the latest from VeEX is actually the same, so there's no need to do the update. Once you see a difference, you can just tick that one here, click download, and you need to have a USB stick formatted as FAT32. Remember, the USB stick has to be formatted as FAT32 file system. Plug it into your unit and then start downloading. Once downloaded, you can reboot and the new firmware will be installed. Once done, you repeat the same process with the other updated files, the other updates available for you to download. So that was for the software updates. We have seen the files. If you have a USB plugged in, you should be able to browse what's on that USB. You can create profiles as well and load them or unload them. In the settings, you can configure, enable or disable your Bluetooth from this section. If you got a USB dongle which is supporting the Bluetooth. If it happens that you get unstable screen or maybe not responsive a bit to your touch screen, to your touches, you can calibrate the screen using that one here. You can also get to know what kind of power source information on your battery. If you click that icon, you can see that it's fully charged. Date and time, this is how you adjust the date and time and your time zone. And more. Yeah, the EZMode section, this one here at the bottom left, that's really important to know. So this is how you connect your unit to the cloud. So you can get remote support from VeEX distributors like us, or maybe get remote support from the team and the head office. So this is how you get your unit to be shared with others so they can control it remotely for you. It's a very nice tool for getting remote support and also for training purposes. So when you get into that section and you already got an IP at the bottom here, you click on apply and the unit will register itself on the DNS cloud of VeEX, which is a free service. So yeah, now the unit has been registered successfully. That's the QR code you need just to scan to be able to log into the unit. If you don't have access to that QR code, you don't know how to share it, the session ID for the remote login would be that session ID number, TMAA. Actually, that's the serial number of the unit. And if you want someone to log in remotely, ask him to go to the website ezremote.vexincorporation.net. Now let's do that. I'll open another tab, ezremote.vexinc.com. So that's the login page for anybody remotely to log in. You type in the serial number of your unit. Let me double check if that's the one here. 107. Alright, need to type that in. I don't have it. Right, you press on connect and you should be able to log in again to the unit, but this time via the cloud. So we are logged in 3 times actually to the unit simultaneously now as we speak. So we've got the VNC, that's this screen, it's that screen. Now the second one is the EZMode on your browser from somewhere remotely, and the third one is through your browser tab by typing in the IP address. So multiple options for you to log in remotely to the unit. So that's pretty much it for the remote support. Now for your Wi-Fi, you need first to have your USB dongle inserted. Once inserted, you will be able to scan the networks around you to connect to. We are already connected to one. So once connected, you'll see the connection established. And there's also another mode called AP mode, access point mode, where you can have the unit, the OTDR, acting as an access point rather than a client. So if you are in the middle of nowhere, there's no wireless around you, and you want to have that OTDR as an acting and as an access point, you start that mode, and then on your smart device or your computer, you scan for the access points around you. You should be able to see a new access point with the name, within SSID, a name the same as the serial number of the unit. Log in with the default password, which is 128, and then you will be able to control the unit remotely while having no wireless around you, which is pretty much handy if you don't want to be standing next or in front of the unit all the time. You can create that access point, walk around, and have access to the unit. Maybe you might be in a place where it's noisy or uncomfortable in the sun. You can just establish that access point and log in with your tablet or your smart device and control it from a distance. The rest of the test modes, just the visual fault locator, you enable your red laser to come out of the unit so you can test patch cables. You turn it on or off, be it a pulse of 1 Hertz or a continuous wave. Too easy to operate. And you got also the laser source and power meter modes, optical light source, and actually the light source will be on the same port as the OTDR port. We're going to be use it as a continuous wave laser. It's not going to be an OTDR. So on the OLS sections, that this is the optical laser source. You turn it on and you choose which laser you want to shoot on your fiber, and you can put a modulation to be detected on the other end. You can also use the optical power meter port and do some measurements once you need to make an acquisition. Acquire, and you see the table here at the top right, acquiring results. And you can also change the wavelength 1310, do another acquisition. Go to your table, you can see your results, the date and time, the power level, and the wavelength. So that was the third test mode in the power meter and laser source on VFL. If you got a fiber scope, it has to be from VeEX, so it can work with the unit, and you will be able to make a pass and fail for the fiber inspection. So that's pretty much it. Thanks for watching. If you need any help or support, just reach out to VeEX or Telecom Test Solutions in Australia and New Zealand. Thanks for watching.